Welcome back everyone, Patrick here. Moving on to the next video, what we got to do is take these pairs of expressions here. We have to find the greatest common factor. So starting with part A, we got 3x and 5x. So first thing I like to do when I get a combination of numbers and variables is I like to start off with the numbers first. So if we look at just 3 and 5 separately, what are the factors of 3? Well, it's just 1 and 3. What are the factors of 5? Well, it's 1 and 5. Now, because 1 is a factor of all integers, we don't look at 1 as a potential greatest common factor because it's always going to be common in all of them, right? So we look at all other factors but 1. So we always ignore 1, and notice that between 3 and 5, 3, 5, those are not common. So there's no common factor between the integers, in this case 3 and 5, but notice that both of these expressions, they do contain the same variable x. And whenever you have the same variable in the expressions that you're finding the greatest common factor for, the greatest common factor is always going to be that variable. It's not just going to be x, actually. I'll just put variable here as the base to the power of the lowest exponent. So in this case, both of these have an exponent of 1, so it would just be x to the power of 1. Okay, and then there's no factor between 3 and 5, so the greatest common factor between these two is just x. Right? So it's always going to be, first off, it has to contain, the variable has to be in all the expressions, and then it's going to be the variable to the lowest exponent. So in part B, we got 6x and 15x. So let's start off with 6 and 15. What are the factors of 6? Well, 1, but we ignore that. Then we got 2, 3, and then 6. What are the factors of 15? 1 we ignore, then it's going to be 3, 5, and 15. So now looking at these, is there a common factor between these? Yes, it's 3, and that's the only common factor, so we don't have to worry about the greatest one. Let's say there were 2 that were common, like let's say there was a 6 over here, then we would take 6 as the greatest common factor, right? But because there's only a 3, that is the common factor between them. So a 3 we could take out. And then also notice that both of these, like in part A, contain that x variable, and that x variable is just to the power 1 in both cases. So 3x would just be the greatest common factor in this case. Moving on to part C, notice there's no integers in this case, there's no constants in front, but we do have the same variable, x to the power 3, x to the power 4. So now the exponents are different. Remember, we take the one with the lowest exponent, so 3 is the lower exponent. So x to the power 3 would be the greatest common factor. Same thing here, y to the power 6, y to the power 10, same variable y, different exponents, take the lowest exponent, so it would just be y to the power of 6. Moving on to part E, 4xy and 12xz. So starting with the numbers, 4 and 12, notice the greatest common factor is going to be 4, right? Because 4 has a factor of 2 and 4, and then 12 has a factor of 2, 3, 4, 6, and 12, right? 12 has a bunch of factors. So notice that 2 and 4 are common in both, but what's the greatest one? Well, it's 4 between them, right? So 4 would be the greatest common factor between the integers, and then notice we have multiple variables here. So let's start off with x. Notice x is in both of them, and it's just x to the power 1. So that's all we would take out. And then notice we have a y over here, but we don't have a y over here. So y is not common in both expressions, so that wouldn't be part of the greatest common factor. And then notice we have a z here, but it's not over here. So z wouldn't be part of the greatest common factor either. It would just be the x value. So that's the greatest common factor there. Over here, 2x cubed and 6x to the 5. Notice that 2 would be the greatest common factor between 2 and 6. And then notice that there's an x in both of them, so we would take x to the lowest exponent. 3 is the lowest exponent. So 2x to the power of 3 is the greatest common factor. In the next video, what we're going to be doing is more algebraic steps where we're not just going to have pairs, but there's going to be signs in between expressions, and then we're going to be taking out the greatest common factor and seeing what's left in that bracket. But this is just a preliminary sort of video before that.